I'm so glad you found your way here. Your brain is quietly processing this moment of solitude, noticing the peaceful space between you and others, measuring connection in ways you never consciously notice. You'll discover what happens inside your mind when no one else is near, and understand why being alone doesn't mean what you think it means. Welcome to Get Sleepy Science. Now settle in. You're in your safe space while your brain quietly measures the distance between you and others, calculating connection and separation in ways you never notice. Allow yourself this moment of peace. We'll journey through 100 psychology facts about solitude, from the neural patterns that emerge in silence, to how your brain rewires itself when no one's watching, to the surprising gift that being alone offers your mind. This thoughtful journey through consciousness builds bridges between searching minds. A gentle like and subscribe helps other sleepless souls discover this peaceful space too. It only takes a moment, but it means the world to us. One quiet tap, one sleepy soul at a time. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You can let these thoughts drift past without holding them. Sense that soothing heaviness enveloping you, like your consciousness slowly dimming its brightness. Thoughts dissolving into the peaceful fog of approaching sleep, safe and undisturbed. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. Your brain processes being alone differently than being lonely. Neuroscientists have discovered that solitude and loneliness activate distinct neural networks with different emotional signatures. When you're alone by choice, your brain's default mode network shows increased activity in regions associated with creativity and memory consolidation. But when loneliness sets in, your brain activates threat detection areas similar to physical pain responses. The anterior cingulate cortex, which processes both emotional and physical pain, lights up during unwanted isolation. This explains why loneliness can actually hurt. Your brain interprets social isolation as a survival threat, triggering stress hormones like cortisol. Yet when solitude feels safe and chosen, these same quiet moments become periods of profound neural regeneration and self-discovery. Solitude strengthens your sense of self in measurable ways. Research in neuroscience has found that people who spend regular time alone show increased activity in the medial prefrontal cortex, the brain region responsible for self-referential thinking and personal identity. During solitary moments, your brain processes questions about who you are, what you value, and what you want from life. This neural self-reflection happens most effectively when external social demands quiet down. College students who spent just 15 minutes alone each day for 2 weeks showed improved self-awareness scores and better decision-making abilities. The silence allows your brain to sort through competing social expectations and rediscover authentic preferences. In constant company, your neural resources stay focused on reading others, predicting reactions, maintaining relationships. But alone, those same neural networks turn inward, strengthening the neural pathways that define your core identity. Your brain craves both connection and solitude in rhythmic cycles. Neuroscientists at Stanford University discovered that the human brain operates on what they call a social homeostasis system. Just as your body regulates temperature and blood sugar, your brain regulates the balance between social interaction and solitary time. When you've been around people too long, Neurons in your brain's lateral hypothalamus release signals that increase your desire for solitude. These same neurons become quiet when you've been alone too long, making social contact feel more appealing. Brain imaging studies show this isn't just preference. It's biological necessity. People forced into constant social interaction show elevated cortisol and decreased cognitive performance. Similarly, people denied adequate social contact show activation in brain regions associated with hunger. Your need for both connection and solitude is as fundamental as your need for food and water. Being alone changes how your brain processes memories. Research from memory consolidation studies reveals that solitary reflection activates specific memory processes that don't occur as readily during social interaction. When you're alone, your hippocampus, the brain's memory center, shows increased theta wave activity. The same neural pattern associated with deep memory encoding during sleep. This means quiet. Solitary moments help your brain organize and store experiences more effectively. Students who spent 20 minutes in solitude after learning new information retained notably more material than those who immediately engaged in social activity. The mechanism involves reduced external stimulation, allowing your brain's attention networks to focus inward. Replaying and strengthening neural pathways formed during recent experiences. In social settings, your brain constantly processes new input. But alone, it finally has space to make sense of what already happened. Weaving individual experiences into coherent narrative memory. Solitude enhances creativity by changing your brain's connectivity patterns. Brain imaging studies using functional MRI have discovered that people in solitary environments show increased connectivity between the default mode network and executive control networks, a pattern associated with creative insight. During alone time, your brain more freely combines distant concepts, makes unusual associations, and explores unconventional ideas. This happens because social situations activate neural circuits for behavioral monitoring and social appropriateness. These circuits, while useful for smooth interaction, actually inhibit the kind of free-flowing thought necessary for creative breakthroughs. Artists, writers, and scientists throughout history have sought solitude not as escape, but as creative necessity. The neural mechanism is clear. Without social oversight, your prefrontal cortex relaxes its inhibitory control, allowing more diverse neural networks to communicate. This is why insights often arrive in the shower, on solitary walks, or in the quiet moments before sleep. Your brain's social prediction systems rest during solitude, conserving significant energy. Researchers at Yale discovered that social interaction requires constant activation of what they call the social brain network. Regions including the temporal parietal junction, superior temporal sulcus, and medial prefrontal cortex. These areas work continuously during social contact to predict others' thoughts, intentions, and emotional states. Brain imaging shows this network consumes roughly 20% of your total neural energy during active social engagement. When you're alone, this network quiets significantly, allowing that energy to redirect toward other cognitive processes. People who spent an hour in solitude showed improved performance on subsequent problem-solving tasks, suggesting the conserved energy became available for analytical thinking. This doesn't mean socializing is bad. It means your brain needs periodic rest from the demanding work of maintaining social connection. just as your muscles need rest after exercise. Solitude affects your brain's perception of time in fascinating ways. Time seems to slow down when you're alone, and neuroscientists now understand why. Your brain's internal clock, governed by the suprachiasmatic nucleus, relies partly on external social rhythms to maintain temporal awareness. During social interaction, constant external events, conversations, reactions, movements, provide temporal markers that make time feel like it's passing quickly. But in solitude, your brain relies more heavily on internal rhythms, heartbeat, breath, thought patterns. Research suggests that people in solitary environments often estimate time passing significantly slower than it actually does. This temporal expansion isn't just perception. It reflects genuine changes in how your brain processes duration. Your anterior insular cortex, which processes time awareness, shows different activation patterns during solitude. The practical implication is beautiful. Solitary moments give you more subjective time, more space for thought, more room for experience to unfold without the rush that social contexts impose. Being alone activates brain regions associated with future planning and imagination. When external social demands fade, your brain naturally shifts into what researchers call prospective mode. The ventromedial prefrontal cortex and posterior cingulate cortex, regions central to imagining future scenarios, show heightened activity during solitary rest. Studies have found that people who spent regular time alone demonstrated better future planning abilities and more detailed mental simulations of potential outcomes. This makes evolutionary sense. Solitude provided our ancestors with critical time to mentally rehearse hunting strategies, anticipate dangers, and plan seasonal migrations without the distraction of immediate social dynamics. Your modern brain retains this capacity. During quiet alone time, you're not just resting, you're unconsciously running simulations, testing possibilities, preparing for futures that haven't yet arrived. This neural preparation, happening beneath conscious awareness, sharpens decision-making and reduces anxiety about uncertain situations. Solitude reduces inflammation throughout your body through specific neural pathways. Research from Carnegie Mellon University revealed that regular periods of chosen solitude decrease activity in the sympathetic nervous system, your body's stress response network. When this system calms, it triggers a cascade of anti-inflammatory effects. Blood tests showed that people who spent 30 minutes daily in solitude had notably lower levels of C-reactive protein, a key inflammation marker linked to heart disease, diabetes, and cognitive decline. The mechanism involves the vagus nerve, which connects your brain to your heart, lungs, and digestive system. During peaceful solitude, vagal tone increases, activating the parasympathetic rest and digest system. This vagal activation doesn't just calm your mind, it literally signals your immune system to reduce inflammatory responses. The inflammation that chronic social stress creates slowly damages tissues throughout your body. Solitude offers not just mental rest, but genuine physical healing. Your brain's ability to feel empathy actually improves after periods of solitude. This seems counterintuitive. Wouldn't constant social interaction enhance empathy? Research suggests the opposite. Neuroscientists discovered that the neural networks responsible for emotional understanding require periodic rest to function optimally. The anterior cingulate cortex and anterior insula, key regions for processing others' emotions, show signs of fatigue after extended social interaction. Like overworked muscles, these regions lose sensitivity when constantly activated, but after solitary rest, their responsiveness increases. People who spent an hour alone before empathy tests showed notably better accuracy in identifying others' emotional states. The researchers coined this empathic renewal. Your capacity for genuine connection with others depends on regular disconnection. The solitary recharging of emotional processing networks ensures that when you do engage with others, you bring your full empathic capacity, not the depleted remainder of an overtaxed system. Solitude changes the physical structure of your brain over time. A longitudinal study following adults over 3 years found that those who maintained regular solitary practices, meditation, quiet walks, journaling, showed increased gray matter density in the hippocampus and prefrontal cortex. These structural changes correlate with improved emotional regulation and enhanced memory function. The mechanism involves neuroplasticity, your brain's ability to physically rewire itself based on experience. During solitude, reduced sensory input allows your brain to focus resources on internal maintenance and structural optimization. New synaptic connections form more readily when competing external demands diminish. Think of it as neural housekeeping that can only happen when guests leave. The cells that support neurons, called glial cells, become more active during quiet periods, pruning unnecessary connections and strengthening important ones. This structural refinement shapes a brain better equipped for both solitary reflection and meaningful social engagement. Being alone affects your brain's production of specific neurotransmitters in measurable ways. Solitude increases activity in neural pathways that produce serotonin, the neurotransmitter associated with contentment and well-being. Research measuring neurotransmitter levels before and after solitary periods shows that serotonin increases measurably, while cortisol, the stress hormone, decreases notably. The increase in serotonin isn't just about feeling good. It affects how your brain processes information, with higher serotonin levels associated with more balanced emotional responses and improved cognitive flexibility. Interestingly, dopamine levels also shift during solitude, not increasing or decreasing dramatically, but stabilizing into a more consistent baseline. In social situations, dopamine spikes and dips with each interaction, creating a neural roller coaster. Solitude offers your dopamine system a chance to regulate, establishing equilibrium that prevents the exhaustion of constant stimulation. Your brain processes sound differently when you're alone. The auditory cortex, which interprets sounds, shows heightened sensitivity during solitude. Environmental sounds that normally fade into background noise, wind, distant traffic, birdsong, become more noticeable and processed with greater detail. Researchers discovered this isn't just increased attention, it's actual changes in neural processing. The superior temporal gyrus shows enhanced response to subtle acoustic features during solitary listening. Evolution likely tuned this sensitivity for survival alone. Our ancestors needed heightened awareness of environmental sounds that might signal danger or opportunity. This enhanced auditory processing creates what musicians and composers have long known. Solitude reveals layers of sound that social settings mask. The same mechanism explains why music can feel more emotionally powerful when you're alone. Your brain processes melodic contours, harmonic progressions, and rhythmic patterns with greater neural resources, creating richer emotional and aesthetic experiences. Solitude triggers what neuroscientists call autobiographical planning, a specific brain state where you naturally review your life narrative and consider future directions. The medial temporal lobe and ventromedial prefrontal cortex activate together during these spontaneous life review moments. Studies have found that people given regular solitary time showed better alignment between their stated values and actual behaviors, suggesting this neural life review process helps maintain personal integrity. During social interaction, your brain focuses on immediate relational dynamics, but alone, it zooms out to larger patterns. Who am I becoming? Does my current path align with deeper values? These aren't just thoughts. They're neural processes that literally reshape future decision-making. Brain scans show that people who engage in regular solitary reflection develop stronger connections between emotional centers and prefrontal planning regions, creating a more integrated decision-making system where values and choices naturally align. Being alone changes your brain's relationship with fear and anxiety in complex ways. For those new to quiet alone time, the brain's protective systems may become more alert at first, as they adjust to reduced social safety signals and this different mode of awareness. But research shows that regular, chosen solitude actually reduces baseline anxiety over time. The mechanism involves habituation of fear responses. Your amygdala learns that being alone doesn't predict danger, gradually decreasing its reactivity. People who practiced regular solitude for 8 weeks showed significant reduction in generalized anxiety scores and measurably decreased amygdala activation in response to uncertain situations. This creates a paradox. Avoiding solitude to escape loneliness, anxiety actually maintains that anxiety, while embracing solitude teaches your brain that aloneness is safe. The difference between frightening isolation and peaceful solitude lives in this neural learning process, where repeated safe experiences gradually rewire ancient threat detection circuits. Solitude enhances your brain's ability to process complex emotions. The neural networks that handle emotional complexity, distinguishing between similar feelings like disappointment and grief, or contentment and joy, require significant processing resources. During social interaction, your emotional processing systems divide attention between your feelings and others' emotional states. But in solitude, your entire emotional processing capacity focuses inward. Studies using experience sampling found that people reported more nuanced emotional awareness during solitary moments, using more specific emotion words and recognizing blended feelings they'd previously missed. Brain imaging confirms this. The insular and anterior cingulate cortex show more differentiated activation patterns during solitary emotional processing. This enhanced emotional granularity isn't just self-indulgent introspection. It's a crucial skill for mental health. People who can finely distinguish their emotional states show better emotional regulation and lower rates of anxiety and depression. Your brain's sense of boundaries between self and others temporarily shifts during extended solitude. The temporoparietal junction, which processes the distinction between self and other, shows altered activity after prolonged alone time. Some meditators and solo wilderness travelers report experiencing a dissolution of rigid self-boundaries, not losing identity but feeling less separated from the environment. Neuroscientific research confirms measurable changes in how the brain represents self versus non-self during extended solitude. This isn't pathological. It may reflect a more fundamental truth about consciousness that social contexts obscure. In constant company, your brain maintains sharp boundaries. You versus them, inside versus outside, but alone. Especially in nature, these neural boundaries soften. The self-representation networks that typically fire distinctly begin showing more distributed, integrated patterns. Whether this represents confusion or clarity remains a deep philosophical question. But the neural changes are real and measurable. Solitude affects your circadian rhythms and sleep quality through specific neural pathways. Your brain's central clock, located in the suprachiasmatic nucleus, synchronizes with both light cycles and social rhythms. When you spend time alone, especially in natural light, your circadian system can more easily reset to its natural rhythm without the confounding influence of social schedules. Sleep studies found that people who spent a weekend in solitary camping conditions, away from artificial light and social demands, reset their circadian clocks toward earlier natural sleep times, with melatonin production beginning closer to sunset rather than being delayed by evening social activities and artificial light. The quality of sleep also improved, with increased slow-wave sleep, the deepest, most restorative stage. Your brain's sleep systems function optimally when freed from socially imposed schedules, finding rhythms that match ancient biological programming. Being alone activates neural networks associated with moral reasoning and ethical reflection. The dorsolateral prefrontal cortex and posterior cingulate cortex, regions involved in moral judgment, show enhanced connectivity during solitary reflection. Philosophers throughout history sought solitude for ethical contemplation, and modern neuroscience reveals why. Social contexts activate neural systems for behavioral conformity and group cohesion, which can actually interfere with independent moral reasoning. Research has found that people made more principled ethical decisions, choices aligned with stated values even when costly, after periods of solitude compared to decisions made in social contexts. This doesn't mean social influences are always corrupting, but it suggests that solitude provides neural space for your authentic moral compass to orient, without the magnetic pull of social expectations, group dynamics, or concern for immediate social consequences. Solitude changes how your brain processes rewards and pleasure. The ventral striatum and nucleus accumbens, key regions in your brain's reward system, show different activation patterns during solitary versus social pleasures. Social rewards: approval, connection, shared joy, typically produce strong dopamine spikes in these regions. But research reveals that solitary pleasures activate a different reward pathway involving the medial prefrontal cortex and posterior cingulate. This pathway produces more sustained, less intense pleasure signals. The difference feels like the contrast between the excitement of a party and the quiet satisfaction of a beautiful sunset. Your brain can experience both types of reward, and both are valuable. But constant social stimulation can overshadow the subtler rewards of solitude, as intense dopamine spikes from social interaction can desensitize reward circuits. Regular solitude maintains the sensitivity of both reward systems, ensuring you can appreciate life's full spectrum of pleasures. Your brain's language processing centers actually quiet during extended solitude, revealing how deeply social our linguistic capacities are. The left inferior frontal gyrus and superior temporal gyrus, core language regions, show decreased activation after hours without conversation. Some solo travelers and meditators report that internal verbal thought diminishes during extended alone time, replaced by more visual and emotional mental content. This isn't language loss, but rather a shift in how consciousness operates without social demands. Language evolved primarily for social coordination. So when social needs fade, linguistic processing naturally quiets. Brain imaging shows this creates space for enhanced visual spatial processing and increased activity in regions associated with visual imagination. Your consciousness can operate in different modes: verbal, analytical during social engagement, more visual intuitive during solitude. Neither mode is superior. Both offer different ways of understanding and experiencing reality. Solitude affects your brain's stress response system in lasting ways. The hypothalamic pituitary adrenal axis, your body's main stress response pathway, shows reduced reactivity after regular solitary practices. But here's what's fascinating. This isn't just lower baseline stress. Your brain actually becomes more resilient to future stressors. Research found that people who maintained regular solitary time showed faster recovery from stress challenges. Their cortisol returned to baseline more quickly than people who avoided solitude. The mechanism involves changes in how your hippocampus regulates the HPA axis. During peaceful solitude, your hippocampus strengthens its inhibitory connections to the amygdala and hypothalamus, creating stronger brakes on stress responses. Think of solitude as training your brain's stress regulation system, like physical exercise that makes your heart stronger for future demands. Solitary rest strengthens the neural circuits that will calm you during life's inevitable storms. Being alone changes how your brain constructs your sense of identity over time. The default mode network, particularly active during solitary rest, plays a crucial role in maintaining what psychologists call narrative identity, the ongoing story you tell about who you are. Neuroscientists discovered that this story-building process happens most actively during unstructured alone time. Your brain takes fragments of memory, current experiences, and imagined futures, weaving them into coherent self-narrative. A longitudinal study found that people who maintained regular solitary reflection showed more stable sense of identity during major life transitions compared to those who avoided solitude. The solitary integration of experiences into ongoing narrative prevents identity fragmentation, the feeling of being pulled in too many directions. Your brain needs quiet time to ask and answer the fundamental question, who am I becoming? The neural processes that address this question can't compete with immediate social demands. They require the spaciousness that only solitude provides. Solitude affects your brain's processing of physical pain in measurable ways. The anterior cingulate cortex processes both social pain, rejection, loneliness, and physical pain through overlapping neural pathways. Research discovered something remarkable. Chosen solitude can actually increase pain tolerance. People who spent 20 minutes in peaceful solitude before pain tests showed notably higher pain thresholds compared to baseline. The mechanism involves endogenous opioid release, your brain's natural painkillers. During restful solitude, the periaqueductal gray matter, a brainstem region that modulates pain, shows increased activity. This creates a state of reduced pain sensitivity that persists for hours. The finding has implications for chronic pain management. Regular solitude might naturally supplement pain treatment by activating your brain's own analgesic systems. The pain-reducing effects of solitude appear strongest when the alone time feels safe and chosen, not imposed or unwanted. Your brain's sense of time depth, the ability to connect past, present, and future into coherent temporal experience, enhances during solitude. The medial prefrontal cortex and hippocampus work together to create what neuroscientists call mental time travel, the capacity to vividly remember the past and imagine the future. Social interaction tends to anchor consciousness in the present moment, as immediate social demands require continuous present-focused attention. But during solitude, your brain more freely moves through time. Studies have found that solitary reflection enhanced both autobiographical memory specificity and future imagination vividness. People could recall personal memories with greater sensory detail and imagine future scenarios with more realistic elaboration. This temporal expansion of consciousness represents one of solitude's profound gifts: freedom to dwell in past wisdom, present awareness, and future possibilities without the constant pull of immediate social demands. Your consciousness becomes more three-dimensional, spanning the full depth of human temporal experience. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of organisms working in silence, heart beating, lungs breathing, brain thinking, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem, diverse, self-balancing. Even in this moment of solitude, you are never truly alone. Countless living processes collaborate within you, creating the experience you call yourself. Now we continue. The quality of your solitude matters more than the quantity, and your brain can distinguish between different types of alone time. Neuroscientists identify at least 3 distinct neural patterns during solitude. Reflective solitude, which activates the default mode network and supports self-understanding. Restorative solitude, which quiets the sympathetic nervous system and promotes healing. And creative solitude, which enhances connectivity between distant brain regions and supports innovation. Studies have found that people naturally cycle through these states during extended alone time, with the brain shifting modes based on current needs. 15 minutes of restorative solitude provides more stress reduction than an hour of distracted alone time spent scrolling devices. Your brain recognizes authentic solitude, free from digital interruption, fully present with yourself, and responds with deeper neural benefits than pseudo-solitude that merely removes other people while maintaining constant external stimulation. Solitude affects your brain's processing of beauty and aesthetic experience. The orbitofrontal cortex and medial prefrontal cortex, regions involved in aesthetic appreciation, show enhanced responsiveness during solitary encounters with beauty, whether viewing art, hearing music, or witnessing natural beauty. Your brain processes aesthetic qualities more deeply when you're alone. This happens because aesthetic processing requires sustained attention without social distraction. In company, part of your neural resources monitor others' reactions. Are they also appreciating this, should I comment? This social monitoring, while valuable for connection, interferes with pure aesthetic absorption. Brain imaging shows that people viewing the same artwork alone versus in company show markedly different patterns. Solitary viewers sustain attention longer and show stronger activation in reward and emotion processing regions. The subjective reports match. People rate aesthetic experiences as more moving and memorable when encountered alone. Beauty speaks most clearly in silence. Your brain's ability to learn new information actually improves after periods of solitude. But not for the reasons you might think. The improvement isn't about focus. Social and solitary learning can both be focused. Instead, solitude enhances learning consolidation. When you acquire new information, your brain doesn't immediately store it as stable long-term memory. That conversion requires offline processing, particularly during rest and sleep. Research shows that quiet, solitary rest periods immediately after learning enhance this consolidation by allowing the hippocampus to replay and reorganize new information without interference. Students who spent 15 minutes in silent solitude after lectures remembered notably more material a week later compared to those who immediately engaged in social activity. The mechanism involves reduced hippocampal interference. New social experiences don't overwrite or compete with what you just learned. Think of solitude as giving your brain's filing system time to properly store information before new input arrives. Solitude changes your relationship with your own thoughts in profound ways. The anterior insula, a brain region involved in interoceptive awareness, sensing internal states, shows increased activity during extended alone time. This means you become more aware of subtle thoughts, feelings, and bodily sensations that social situations obscure. But here's what's fascinating. This increased awareness doesn't always feel comfortable. Studies have found that people unused to solitude initially experienced increased anxiety when asked to sit alone with their thoughts for just 15 minutes. Their brains, unaccustomed to turning attention fully inward, encountered uncomfortable thoughts and feelings typically buried beneath social distraction. However, people who regularly practiced solitude showed the opposite response. Their resting brain state involved greater comfort with internal experience. The difference suggests that your brain needs training to tolerate its own contents. Solitude serves as that training, gradually building comfort with the full spectrum of internal experience. Being alone affects your brain's production of brain-derived neurotrophic factor, a protein essential for neural health and growth. BDNF supports the survival of existing neurons and encourages growth of new neurons and synapses. While exercise is well known to increase BDNF, research reveals that mindful solitude produces similar effects through different mechanisms. When your brain rests from social demands, stress hormones decrease and BDNF production increases, particularly in the hippocampus. People who maintained 30 minutes of daily solitary practice showed notably higher BDNF levels after 8 weeks. Higher BDNF correlates with better memory, enhanced mood, and greater cognitive flexibility. The finding suggests that solitude isn't just psychologically beneficial. It promotes actual neurobiological growth. your brain physically adapts to regular solitude, building stronger, more resilient neural architecture that serves you during both alone time and social engagement. Solitude affects your microbiome, the trillions of bacteria living in your gut, which in turn affects your brain through the gut-brain axis. This bidirectional communication pathway means your emotional state influences gut bacteria, and gut bacteria influence your emotional state. Research found that chronic social stress alters gut microbiome composition in ways that promote inflammation and anxiety. But regular solitary rest appears to partially reverse these changes. People who practiced daily solitude showed increased diversity of beneficial gut bacteria and reduced levels of species associated with anxiety and depression. The mechanism involves the vagus nerve, which carries signals between your brain and gut. During peaceful solitude, increased vagal tone promotes healthier gut conditions, which then send signals back to your brain supporting calmer mood states. This creates a beneficial feedback loop. Solitude calms your brain, which improves your gut health, which further calms your brain. Your relationship with being alone literally shapes the microscopic ecosystem inside you. Your brain's social prediction errors, moments when social reality violates expectations, require significant neural processing to resolve. The anterior cingulate cortex lights up when social experiences don't match predictions. Unexpected rejection, surprising acceptance, confusing reactions. These prediction errors, while valuable for learning, consume substantial cognitive resources. Solitude offers your brain a break from constant social prediction and error correction. Without others' unpredictable behavior, your brain's prediction systems can rest. Studies have found that people showed improved emotion regulation after solitary periods, particularly for emotions triggered by social unpredictability. The researchers suggested that solitude allows the brain's social processing networks to reset, clearing accumulated prediction errors and reducing the cognitive load of maintaining complex social models. When you return to social contexts after solitary rest, your social cognition functions more smoothly, making more accurate predictions and adapting more gracefully when predictions fail. Solitude changes how your brain processes existential questions about meaning and purpose. The posterior cingulate cortex and medial prefrontal cortex, regions involved in self-reflective thought, show distinctive patterns during contemplation of life's bigger questions. Philosophers and spiritual seekers throughout history have sought solitude for such contemplation, and neuroscience now explains why. Social contexts activate brain networks focused on immediate relational concerns. What does this person think of me? How should I respond? What's my role here? These concerns, while important, occupy neural resources that might otherwise address deeper questions. Why am I here? What matters most? What do I believe? Brain imaging shows that solitary reflection allows these existential processing networks to activate without competition. People who maintained regular contemplative solitude reported greater sense of meaning and purpose compared to those who filled all available time with social activity or entertainment. Meaning emerges not from busyness, but from stillness. Neural space to process life's ultimate questions. Being alone affects your brain's reward system in ways that influence your relationship with material possessions. The nucleus accumbens, a key reward region, shows reduced activation in response to material goods after periods of solitude. particularly solitude in nature. Research found that people who spent a weekend in solitary wilderness conditions reported decreased desire for consumer purchases and greater satisfaction with what they already owned. Brain scans confirmed reduced reward system reactivity to shopping-related images. The mechanism appears related to shifted baseline dopamine levels. Constant social comparison, keeping up with others, status signaling through possessions, keeps dopamine reward systems primed for material acquisition, but solitude interrupts this cycle. Without comparative context, your brain's reward systems recalibrate to more intrinsic sources of satisfaction, experiences, beauty, understanding. The shift isn't permanent. Social context quickly reactivates material desires, but it reveals how deeply our consumer impulses depend on social context rather than genuine need. Solitude affects your brain's processing of forgiveness in unexpected ways. The dorsolateral prefrontal cortex and temporal parietal junction, regions involved in perspective taking and emotional regulation, show enhanced connectivity during solitary reflection on interpersonal hurts. Forgiveness, whether of others or yourself, requires complex neural processing. Understanding another's perspective, regulating your own emotional reactions, revising social narratives. This processing happens more effectively during solitude than during social interaction. Studies have found that people who engaged in solitary reflection after interpersonal conflicts showed faster forgiveness and emotional resolution compared to those who immediately discussed conflicts with others. The researchers suggested that social discussion, while valuable, can reinforce grievances through repeated verbal rehearsal and social validation of hurt. Solitude offers your brain space to naturally process emotions, consider multiple perspectives, and arrive at authentic forgiveness rather than socially performed reconciliation. True emotional resolution often requires privacy. Your brain's sense of wonder and awe responds more powerfully to experiences encountered in solitude. The anterior insular and anterior cingulate cortex show heightened activation during awe-inducing experiences. And this activation intensifies when you're alone. Awe. That feeling of encountering something vast that transcends current understanding requires full cognitive immersion, social presence, even friendly presence, partially diverts attention from the awe-inducing stimulus to social monitoring. Brain imaging studies comparing people viewing the Grand Canyon alone versus in groups show markedly different patterns. Solitary viewers sustain attention longer, show stronger emotional processing activation, and report more profound experiences. This doesn't mean shared awe is inferior. Shared experiences offer their own unique value. But it suggests that the deepest encounters with transcendent beauty often require solitude. Your brain can fully surrender to wonder only when freed from all social demands, including the subtle demand to acknowledge others' simultaneous experience. Solitude affects your brain's processing of gratitude in measurable ways. The anterior cingulate cortex and medial prefrontal cortex, regions involved in positive emotions and self-reflection, show specific activation patterns during grateful reflection. Research found that people who practiced solitary gratitude reflection, quietly contemplating what they appreciate without social performance, showed increased activity in these regions and reported more authentic feelings of appreciation. The key distinction involves performance versus genuine emotion. social expressions of gratitude, while valuable for relationships, partially activate brain regions associated with social compliance and impression management. But solitary gratitude reflection activates purer emotional processing networks. Brain scans show that people thinking grateful thoughts alone show stronger activation in reward and emotion regulation regions compared to people expressing gratitude to others. Both forms of gratitude offer benefits, but solitude allows your brain to access gratitude as pure emotional experience rather than social obligation. Being alone changes your brain's relationship with uncertainty in complex ways. The anterior cingulate cortex and orbitofrontal cortex process uncertainty and ambiguity, showing heightened activation when you encounter unpredictable situations. Social contexts often increase uncertainty. Will they like me? What will happen next? How should I respond? Keeping these brain regions constantly active. But solitude offers your brain a break from social unpredictability. In solitary environments, especially familiar solitary spaces, your brain's uncertainty monitoring systems can rest. Research found that regular solitary time in consistent locations, the same park, the same room, reduced baseline anxiety by allowing the brain to establish predictable environments where uncertainty monitoring could diminish. This creates neural rest that enhances your capacity to handle inevitable uncertainties when they arise. Your brain handles life's unpredictability more gracefully when it has regular refuge in predictable solitude. Solitude affects your brain's processing of personal values and priorities. The ventromedial prefrontal cortex, crucial for value-based decision-making, shows enhanced activity during solitary reflection on what matters most. In constant social contexts, your brain's value systems receive continuous external input, others' opinions, social norms, cultural expectations. These inputs aren't inherently problematic, but they can obscure personal values. Brain imaging reveals that solitary value reflection activates different neural patterns than social value discussion. Solitary contemplation shows stronger connectivity between emotion processing regions and prefrontal decision-making areas, suggesting deeper integration of feelings and values. Studies have found that people who maintained regular solitary value reflection made life decisions more aligned with stated core values, compared to people who processed values primarily through social discussion. The difference suggests that knowing what you truly value, as opposed to what you should value or what others value, requires periodic removal from social influence. Your brain's default mode network, active during rest and self-reflection, shows its most integrated activity patterns during comfortable solitude. This network, including the medial prefrontal cortex, posterior cingulate cortex, and angular gyrus, creates what neuroscientists call the neural signature of self. The brain patterns that represent your continuous sense of being you. Social interaction partially suppresses default mode network activity as attention shifts outward to others. But during peaceful solitude, this network activates fully, allowing your brain to process self-relevant information, consolidate identity, and integrate experiences into ongoing narrative. Research found that people who regularly experienced quality solitude showed more coherent default mode network connectivity, correlating with stronger sense of identity and better emotional well-being. The finding suggests that a stable sense of self depends on regular time when your brain can activate its core self-processing networks without competing social demands. You need to be alone with yourself to remain yourself. You're still here with me. Thoughts still flickering like candlelight. Just notice. Don't judge. Just notice where your mind is. We're exploring consciousness itself. The very thing doing the exploring right now. Strange, beautiful, and perfectly calm. Let's drift onward together. Solitude affects your brain's processing of mortality awareness in profound ways. Terror management theory suggests that humans cope with death awareness through cultural worldviews and relationships. But recent neuroscience reveals that solitude offers another path. The medial prefrontal cortex and posterior cingulate show distinctive activation during solitary contemplation of mortality, not the anxious rumination that can occur in isolation, but peaceful acceptance that emerges from deep reflection. Research found that people who regularly practiced solitary contemplation, including meditation on impermanence, showed reduced anxiety about death and greater life satisfaction. Brain imaging confirmed reduced amygdala reactivity to death-related concepts. The mechanism appears related to integration. Solitude allows your brain to fully process existential realities that social contexts encourage redirecting from. When you can sit peacefully with the deepest truths, including your own finitude, anxiety about those truths naturally diminishes. Being alone changes how your brain processes silence itself. Silence isn't absence. It's a presence that your brain actively processes. The auditory cortex remains active during silence. And research shows this activity differs between solitary and social silence. Social silence can feel awkward, as your brain monitors for social meanings. Are they angry? Should I speak? But solitary silence allows your auditory system to process subtle environmental sounds, usually masked by social noise. Studies have found that regular exposure to solitary silence produced measurable changes in auditory cortex sensitivity. People could detect quieter sounds and showed enhanced appreciation for subtle acoustic environments after periods of silent solitude. The researchers suggested that silence in solitude offers your auditory system a reset, clearing the constant noise that modern social life creates and restoring your brain's capacity to appreciate subtle sonic experiences. Solitude affects your brain's mirror neuron system. Neurons that fire both when you act and when you observe others acting. These neurons, crucial for empathy and social learning, show reduced activity during solitude. Initially, this seems concerning. Less empathy, but extended research reveals benefits. The mirror neuron system can become overactive, leading to emotional contagion and empathy fatigue. Healthcare workers, for example, often experience burnout partly from continuous activation of mirror neuron systems responding to others' suffering. Solitude offers this system necessary rest. Studies have found that nurses who practiced daily solitude maintained stronger empathy over time compared to those who didn't, suggesting that, paradoxically, periodic disconnection preserves connection capacity. Your brain's empathy systems, like any biological system, require recovery periods to function optimally across years and decades. Your brain processes hierarchy and status differently during solitude. The dorsolateral prefrontal cortex and anterior cingulate cortex normally track social rank continuously, where you stand relative to others, who has higher status, how to navigate hierarchies, These rankings happen largely unconsciously but consume significant neural resources. During solitude, status monitoring activity dramatically decreases. Brain imaging shows reduced activity in hierarchical processing regions during alone time. This neural shift explains the relief many people feel when alone. Temporary freedom from constant status assessment. Research found that people made more authentic decisions, choices reflecting personal values rather than status concerns. After periods of solitude, the temporary removal from hierarchical contexts allows your brain's decision-making systems to operate without status-related biases. You glimpse who you are, independent of social rank, revealing preferences and values that hierarchical contexts obscure. Solitude affects your brain's processing of humor and laughter in unexpected ways. Laughter is predominantly social. We laugh 30 times more frequently in company than alone. But the type of humor your brain produces during solitude differs from social humor. The medial prefrontal cortex and temporal parietal junction, regions involved in theory of mind and social cognition, show different activation when you find something funny alone versus laughing in company. Social laughter activates circuits related to bonding and group cohesion, but solitary amusement, recognizing irony, appreciating absurdity, finding unexpected connections, activates circuits more related to insight and cognitive flexibility. Research suggests that solitary humor serves different purposes, not social bonding but cognitive play, allowing your brain to explore unusual connections and perspectives without social judgment. The humor that emerges in solitude often differs in content and quality from social humor, revealing different cognitive processes. Being alone changes your brain's relationship with nostalgia and memory. The hippocampus and posterior cingulate cortex collaborate during nostalgic remembering, and their activation patterns differ during solitary versus social reminiscence. Solitary nostalgia tends to focus on intrinsic emotional memories, how you felt, what experiences meant to you personally, while social nostalgia often emphasizes shared memories and collective narratives. Brain imaging shows that solitary nostalgic reflection produces stronger activation in emotion processing regions, suggesting deeper emotional engagement with memories. This doesn't make solitary nostalgia superior. Shared memories offer their own richness, but it reveals that your brain accesses different aspects of the past, depending on social context. Solitude allows memories to surface in their original emotional texture, uncensored by social presentation concerns or reshaped by collaborative storytelling. You remember differently when no one else is shaping the narrative. Solitude affects your brain's processing of curiosity in measurable ways. The caudate nucleus and anterior cingulate cortex, regions involved in curiosity and information seeking, show heightened activation during solitary exploration of new ideas. Curiosity in social contexts often involves performance, showing others how knowledgeable or interested you are. But solitary curiosity operates purely for intrinsic satisfaction. Research found that people exploring new topics alone showed different learning patterns than people learning in groups. Solitary learners followed more idiosyncratic paths, spent more time on personally interesting tangents, and showed better retention of self-selected information. The mechanism involves reduced social monitoring, allowing your brain's curiosity systems to follow intrinsic interest rather than externally appropriate paths. This creates what researchers call authentic curiosity. learning driven purely by wonder rather than social approval or practical necessity. Your brain's processing of regret and counterfactual thinking, imagining how things might have gone differently, intensifies during solitude. The orbitofrontal cortex and medial prefrontal cortex generate alternative scenarios and evaluate past decisions. Social contexts often suppress this processing, as others encourage moving forward rather than dwelling on the past. But research suggests that solitary counterfactual thinking, while sometimes uncomfortable, serves important functions. Your brain needs to process regret to extract lessons and update decision-making models. Studies have found that people who engaged in structured solitary reflection on past decisions showed better future decision-making compared to those who immediately distracted themselves or sought social comfort. The key is allowing full processing without rumination. Your brain naturally moves through regret toward acceptance and learning if given undistracted time. Solitude provides that processing space. Solitude changes how your brain processes hope and optimism. The anterior cingulate cortex and prefrontal regions involved in future simulation show specific patterns during hopeful thinking. Social hope often involves shared goals and collective optimism, activating social bonding circuits. But personal hope, optimism about your own future, independent of others' approval, activates different networks. Brain imaging reveals that solitary reflection on personal possibilities produces stronger activation in regions associated with internal motivation and autonomous goal setting. Research found that people who practiced regular solitary future imagining exercises showed increased goal pursuit and greater resilience in face of setbacks. The mechanism involves your brain's ability to generate authentic motivation when freed from social expectations about what you should want or who you should become. Hope that emerges in solitude carries your brain's genuine expectations for your own future. Being alone affects your brain's relationship with its own thoughts through metacognition. Thinking about thinking. The anterior prefrontal cortex, the most evolutionarily recent part of your brain, enables this recursive self-awareness. During solitude, metacognitive processes naturally activate. You notice that you're thinking. Observe your thought patterns. Recognize recurring mental habits. This self-observation happens less during social interaction, as attention directs outward. Research shows that regular solitary reflection improves metacognitive accuracy. Your ability to correctly assess your own understanding, recognize knowledge gaps, and monitor thought quality. People who practice daily solitary reflection showed better calibration between confidence and actual knowledge. This improved self-awareness has practical benefits: better decision-making, enhanced learning, reduced overconfidence. Your brain needs periodic solitude to observe itself, creating the self-awareness that social contexts, with their outward focus, cannot provide. Let each breath guide you to realize time is yours, a separate stream that only you are living, while the vast universe continues to spin, expand, change. This second you're breathing, listening, is unique. Cherish the present moment, knowing that right now, your time is unique in the universe. Even in this solitude, you're connected to everything, every star that ever burned, every person who ever wondered about being alone, every consciousness that ever questioned its own existence. You're both separate and connected, alone and universal. And we continue drifting. Your brain's relationship with solitude changes across your lifespan in predictable ways. Brain development research shows that adolescent brains often find solitude more challenging than adult brains. The social sensitivity of teenage years involves heightened activity in social processing regions and stronger emotional responses to peer exclusion. But as the prefrontal cortex fully matures through the mid-20s, tolerance for solitude typically increases. Older adults often report greater comfort with alone time, and brain imaging confirms why. Reduced amygdala reactivity to social absence and stronger default mode network connectivity supporting satisfying internal experience. This developmental trajectory suggests that learning to be comfortably alone is partially a process of neural maturation. Your brain gradually builds capacity for satisfying solitary experience. Solitude affects your brain's immune signaling in ways that influence physical health. The vagus nerve carries signals between brain and immune system, and solitary rest increases vagal tone, a measure of parasympathetic nervous system activity. Higher vagal tone correlates with reduced inflammation, faster healing, and stronger immune responses to pathogens. Research found that regular solitary practices decreased inflammatory markers and improved immune function over 8 weeks. The mechanism involves reduced social stress, allowing your brain to shift from threat mode to healing mode. Chronic social demands keep your immune system slightly activated, preparing for potential threats. Solitude signals safety, allowing immune resources to redirect from defense to maintenance and repair. Being alone changes how your brain processes rhythm and temporal patterns. The cerebellum and basal ganglia, regions involved in timing and rhythm perception, show altered activity during solitary listening to music or natural rhythms, without social rhythms to entrain to. The timing of conversation, shared activities, coordinated movements. Your brain's internal rhythm generators can synchronize more fully with external rhythms like music, rain, or heartbeat. This explains why music often feels more absorbing when you're alone. Your neural timing systems can fully align with acoustic rhythms without competing social temporal demands. Some researchers suggest this temporal freedom partially explains why solitary walks in nature feel restorative. Your brain's rhythms can synchronize with natural patterns rather than social schedules. Solitude affects your brain's generation of insights through incubation effects. When you stop actively working on a problem, your brain continues unconscious processing. This incubation works most effectively during solitary rest, when competing cognitive demands diminish. The anterior superior temporal gyrus, involved in insight moments, shows heightened activity during rest periods following focused work. Research found that people who took solitary breaks after studying complex problems showed notably more insight solutions than those who took social breaks. Conversation during breaks, while enjoyable, occupies working memory and attention networks needed for unconscious problem processing. Solitude offers your brain the quiet necessary for ideas to percolate and connections to form beneath conscious awareness. Your brain processes trust and betrayal differently during solitary reflection compared to immediate social contexts. The anterior insular and anterior cingulate cortex activate during processing of social trust violations. But immediate social processing often triggers defensive reactions rather than understanding. Solitary reflection allows deeper processing, The medial prefrontal cortex, involved in mentalizing about others' mental states, shows stronger activation during alone time, reflection on interpersonal difficulties. Research suggests this leads to more nuanced understanding of others' motivations and more balanced attributions. People who took solitary time to reflect on conflicts showed more generous interpretations of others' behavior compared to immediate reactions. The mechanism involves reduced threat response, allowing more sophisticated social cognition. Solitude enhances your brain's ability to distinguish between authentic joy and socially conditioned desires. The ventral striatum, part of your reward system, shows more selective activation during solitary reflection on past experiences. Brain imaging reveals stronger responses to genuinely fulfilling memories, while showing reduced activation for achievements that impressed others but felt personally empty. This neural discrimination, sharpened through regular alone time, helps guide future choices toward authentic satisfaction rather than external validation. You learn what you actually want, not what you've been taught to want. The quiet space of solitude allows your brain's reward systems to recalibrate away from socially impressive goals toward personally meaningful ones, creating alignment between outer achievement and inner fulfillment. Being alone affects your brain's processing of language in its absence. During extended solitude, especially silent solitude, the left hemisphere language centers show reduced metabolic activity, while right hemisphere spatial and emotional processing regions become more active. Some long-distance solo sailors and hermits report that words begin to feel strange after extended silence, as if language itself becomes foreign. This shift isn't pathological, but rather reveals how heavily our normal consciousness relies on linguistic processing. When language quiets, other forms of cognition, spatial, emotional, imagistic, become more prominent. Your consciousness can operate in multiple modes, and solitude reveals non-linguistic modes typically overshadowed by constant verbal thought. Solitude affects your brain's processing of faces and facial recognition. The fusiform face area, specialized for recognizing faces, shows reduced activity during extended solitude. Some solo travelers report that faces temporarily look strange after days without seeing people. But this isn't impairment. It's adaptation. Your brain allocates neural resources based on environmental demands. When faces become rare, the fusiform face area partially reallocates to processing other visual information. The plasticity is reversible. Recognition ability returns quickly with social re-engagement. The finding reveals how flexibly your brain adapts to environmental statistics. When social information becomes scarce, neural resources redirect to currently relevant processing. Your brain's processing of meaning and purpose shows specific patterns during solitary contemplation that differ from social processing. The angular gyrus and posterior cingulate cortex, involved in constructing personal meaning, activate strongly during alone time reflection on life purpose. Social contexts often involve externally defined meanings: career success, social status, cultural narratives, but personal meaning requires internal processing. Brain imaging shows that solitary contemplation of personally meaningful memories and future possibilities produces more integrated activation across multiple brain networks, suggesting holistic processing of what matters. People who maintained regular contemplative solitude reported greater clarity about life purpose and more satisfaction with life direction. Solitude, affects your brain's relationship with uncertainty about the future through specific neural mechanisms. The anterior cingulate cortex monitors prediction errors. When reality violates expectations, social contexts generate constant prediction errors as others behave unpredictably. But during solitude, prediction monitoring can rest. This creates space for your prefrontal cortex to engage in broad future simulation without immediate prediction testing. Research shows that solitary future imagining produces more creative, less constrained scenarios than social future discussion. Your brain explores wilder possibilities when freed from social reality checking. And some of these explorations yield genuine insights about potential futures. Being alone changes how your brain processes criticism and negative feedback. The anterior cingulate cortex and medial prefrontal cortex show intense activation when receiving social criticism. But solitary reflection on the same criticism produces different patterns. Reduced threat response. Increased perspective taking. Research found that people who took solitary time to process criticism showed better ability to extract useful information from negative feedback compared to those who immediately sought social support. The mechanism involves reduced emotional flooding, allowing cognitive processing. Immediate social support, while comforting, can reinforce defensive reactions. Solitude allows your brain to move past defensive responses toward genuine learning. Solitude affects your brain's generation of personal rituals and meaningful routines. The basal ganglia, involved in habit formation, show distinctive patterns during development of solitary rituals. Morning coffee alone, evening walks, meditation practice. These personally meaningful routines activate reward processing regions differently than socially obligated rituals. Brain imaging reveals that self-chosen solitary rituals produce activation patterns associated with intrinsic motivation and authentic engagement. Regular solitary rituals help your brain mark time, create structure, and maintain continuity of self across days and years. They serve as neural anchors, reminding your brain who you are, independent of social roles. Your brain processes beauty differently in solitude versus company. The experience of beauty activates reward regions and emotion processing areas, but aesthetic experience deepens when you're alone. Research shows that solitary encounters with beauty produce more sustained attention, stronger emotional responses, and more lasting memory encoding. The mechanism involves undivided attention. Your entire aesthetic processing capacity focuses on the beautiful object, without splitting resources to monitor others' reactions. Some aesthetic experiences may require solitude to be fully appreciated, suggesting that certain types of beauty speak to individual consciousness rather than collective experience. Solitude affects your brain's relationship with your own mortality in unexpected ways. The medial prefrontal cortex processes self-relevant information, including awareness of personal finitude. Social contexts often involve collectively redirecting from death discussions as groups avoid mortality topics. But solitary contemplation allows your brain to fully process existential realities. Research shows that people who engaged in regular solitary reflection on impermanence reported reduced anxiety about death and greater appreciation for present moments. The brain mechanism involves habituation. Repeated exposure to mortality thoughts in safe contexts reduces threat response. Solitude provides the safe context for this exposure. Being alone changes how your brain constructs counterfactual narratives about your life. The orbitofrontal cortex generates alternative versions of your life story. What might have happened if you'd made different choices? Social contexts constrain these narratives through shared histories and others' memories. But solitary reflection allows more freedom in narrative construction. You can explore alternative life paths. Imagine different identities. Consider roads not taken. This isn't self-deception, but rather a form of psychological flexibility. Your brain needs to consider multiple possible selves to make wise decisions about which self to become. Solitude provides the freedom for this essential exploration. Solitude affects your brain's processing of gratitude in lasting ways. The anterior cingulate cortex shows sustained activation during grateful reflection. But social expressions of gratitude, while valuable, partially activate performance-related brain regions. Solitary gratitude involves purer emotional processing. Research shows that people who practiced solitary gratitude reflection reported more authentic appreciation and showed stronger activation in emotion and reward regions. The finding suggests that some positive emotions need privacy to fully develop. Your brain can access deeper gratitude when freed from social expectations about how gratitude should be expressed. Your brain's relationship with personal values clarifies through solitary reflection. The ventromedial prefrontal cortex processes value-based decisions. Social contexts continuously feed your brain information about what you should value. But knowing what you actually value requires internal processing. Brain imaging shows that solitary value reflection produces stronger connectivity between emotion processing and decision-making regions. People who maintained regular solitary reflection made life choices more aligned with stated values. Your brain needs quiet to distinguish authentic values from internalized social expectations. And solitude provides that discriminating quiet. Solitude affects how your brain processes personal growth and identity change. The default mode network constructs ongoing self-narrative. And this narrative requires updating as you change. Social contexts can lock you into fixed identities as others' perceptions create consistency pressure. But solitude allows your brain to revise self-narrative without external resistance. Research shows that people who maintained regular solitary reflection during major life transitions reported smoother identity integration. Your brain can more freely explore emerging aspects of self when old social expectations temporarily release. Solitude creates space for becoming who you're becoming. Being alone changes your brain's processing of hope for humanity and collective futures. The temporal parietal junction, involved in perspective taking, shows activation during contemplation of shared human challenges. Interestingly, solitary reflection on collective problems can produce more optimistic and creative solutions than group problem solving. The mechanism involves reduced social conformity. Alone, your brain can consider solutions that social contexts might dismiss as unrealistic. Some of humanity's most hopeful visions emerged from solitary contemplation rather than committee meetings. Solitude frees your brain to imagine radically better futures without social constraints. Solitude affects your brain's relationship with personal authenticity. The medial prefrontal cortex processes questions of authenticity. Am I being true to myself? Social contexts create pressure towards socially acceptable presentation. But solitary reflection allows your brain to access genuine preferences, feelings, and values. Brain imaging shows that people reporting high authenticity show stronger connectivity between emotion processing and self-representation regions. Regular solitary time strengthens these connections, allowing more consistent access to authentic self across various social contexts. You learn who you really are, not through others' mirrors, but through extended time with yourself. Your brain processes the boundary between self and world differently during solitude. The temporoparietal junction normally maintains sharp distinction between self and not self. But during meditative solitude, especially in nature, these boundaries can soften. Brain imaging shows reduced activity in self-other discrimination regions during deep meditation. This doesn't represent confusion, but rather access to a different mode of experiencing. Less separated, more interconnected. Some contemplatives suggest this represents truth about consciousness that ordinary social awareness obscures. The neural changes are measurable and consistent across cultures. Solitude affects your brain's processing of personal history and life narrative. The hippocampus and medial prefrontal cortex collaborate to construct coherent life stories. Social contexts shape these narratives through shared memory and others' versions of events. But solitary reflection allows your brain to construct narratives based purely on internal memory and meaning-making. Research shows that people who engaged in regular life review during solitary time reported greater sense of narrative coherence and life satisfaction. Your brain needs privacy to honestly assess your life's trajectory and revise narratives that no longer serve growth. Being alone changes how your brain processes the relationship between thought and action. The supplementary motor area and prefrontal cortex coordinate intention and action. Social contexts create immediate action demands. Respond, engage, perform. But solitude creates space between thought and action. Your brain can fully process intentions before acting on them. This creates what philosophers call practical wisdom, the capacity to think before acting. Research shows that regular solitary contemplation improves impulse control and decision-making quality. The mechanism involves strengthening prefrontal inhibitory control through practice during low-pressure solitary contexts. Solitude affects your brain's generation of personal philosophy, your understanding of how life works and what matters. The angular gyrus and posterior cingulate cortex integrate information from multiple sources to construct worldview. Social contexts provide ready-made philosophies through culture, education, and shared beliefs. But developing personal philosophy requires internal integration. Brain imaging shows that solitary contemplation produces more integrated activation across diverse brain regions, suggesting holistic processing. People who maintained regular contemplative solitude developed more nuanced personal philosophies, showing influence from multiple traditions rather than simple acceptance of cultural defaults. Your brain's relationship with being alone is itself changing through regular solitary practice. Neural plasticity means repeated experiences reshape brain structure and function. People who maintain regular solitary practices show measurable brain changes over months. Increased gray matter in regions supporting self-reflection. Enhanced connectivity in default mode network. Reduced reactivity in threat detection regions. These changes create a virtuous cycle. Solitude becomes more comfortable, which encourages more solitude, which further develops neural capacity for satisfying alone time. Your brain can learn to be peacefully alone. And that learning creates physical changes supporting deeper, more rewarding solitary experience. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles, your chest rising and falling, thoughts appearing and dissolving. sensations emerging and fading. Everything moves in circles, cycles, endless rhythms. Even solitude and connection cycle through your life like seasons. You're not meant to always be alone or always be together. Both states have their time and purpose. Like your breath. Inhale, exhale, inhale, exhale. A small cycle within the vast patterns. You are also part of that eternal movement. You don't need to hold on to anything. Let everything unfold in its perfect order. Like planets silently rotating in their orbits. Unhurried, unresisting, simply existing. We're almost there now. The deepest gift of solitude isn't isolation. It's meeting yourself completely. Your brain creates a self-representation that social contexts partially obscure. Alone, without mirrors of others' perceptions, your brain can access its authentic self-model. This self isn't better or worse than social self, just more fundamental. Research shows that people with regular solitary practice report stronger sense of identity and greater comfort with themselves. You discover not loneliness, but presence. The simple fact of existing, regardless of who's watching. Solitude teaches your brain that you're sufficient company for yourself. The anterior insula processes this self-sufficiency, learning through experience that consciousness itself can be satisfying. This isn't selfish. It's liberation. When your brain knows you can be happy alone, relationships shift from need to choice. Connection becomes gift rather than requirement. Brain imaging shows that people comfortable with solitude also form healthier attachments. Not despite solitude, but because of it. Being alone reveals that your thoughts are visitors, not you. The medial prefrontal cortex normally identifies strongly with thought content, but during deep solitary reflection, this identification loosens. You notice thoughts arising and passing like weather. This metacognitive distance, measurable through brain imaging, provides freedom. You are not your anxious thoughts or sad thoughts. You're the awareness in which thoughts appear. Solitude offers space to discover this distinction. Your brain processes the paradox that being alone connects you to everything. When social boundaries soften during solitude, especially in nature, you sense belonging to larger systems, ecosystems, planet, universe. This isn't fantasy. Brain regions processing self-world boundaries show measurable changes. You're physically made of stardust, breathing air recycled through countless beings. Solitude lets your brain recognize interconnections that social focus obscures. Solitude changes how your brain relates to silence as presence rather than absence. The auditory cortex processes silence actively. In deep solitude, you notice silence isn't empty. It's full of subtle sounds and spaciousness. Your brain learns to appreciate silence as valuable experience. This capacity carries into relationships. You become comfortable with quiet companionship, not needing constant verbal filling. Silence becomes connection rather than awkwardness. Being alone teaches your brain that rest is productive. Western culture often treats solitary rest as laziness. But neuroscience reveals essential value. Your default mode network does crucial work during rest, consolidating learning, integrating experience, maintaining identity. Regular solitude strengthens this network. Your brain becomes more efficient, more creative, more balanced. Rest in solitude isn't avoidance. its maintenance. Solitude reveals that you carry relationships within you. The medial prefrontal cortex maintains representations of important others. These internal representations remain active even when people are absent. You're never entirely alone. You carry the love, lessons, and presence of others in your neural networks. Solitude allows processing these internal relationships, strengthening bonds through reflection rather than contact. Your brain discovers during solitude that thoughts slow naturally when not fueled by interaction. Social engagement keeps your verbal systems active, but alone, thoughts gradually space out. Between thoughts, gaps appear, moments of pure awareness. These gaps aren't emptiness, but presence. Brain imaging shows reduced language center activity and enhanced present moment awareness. You glimpse consciousness itself, not just thought content. Solitude teaches your brain that it's okay not to know. The anterior cingulate cortex normally signals uncertainty as problem requiring solution. Social contexts pressure toward confident answers. But alone, you can rest in not knowing. Questions can remain open. Mysteries don't require immediate resolution. This uncertainty tolerance, measurable through reduced anxiety during ambiguous situations, creates wisdom, comfort with life's fundamental unknowability. Being alone reveals that your presence matters even when no one sees. Social validation triggers dopamine rewards. But solitary existence activates deeper networks. Your brain can find intrinsic value in existing, regardless of external recognition. This isn't pride, it's acceptance. You matter not because others notice, but because you're here, conscious, experiencing. Solitude teaches this fundamental self-valuing. Solitude shows your brain that time is yours to inhabit fully, without social schedules fragmenting attention. You can sink into temporal depth. Minutes expand. Present moment deepens. Your brain's temporal processing shifts from clock time to experiential time. This creates what researchers call temporal spaciousness. Feeling of having enough time. Not because you have more, but because you're fully present with what you have. Your brain learns through solitude that peace doesn't require changing anything. The constant social drive toward improvement, progress, achievement quiets. In stillness, your brain can accept things as they are. This isn't resignation, but wisdom. Brain regions involved in striving and discontent show reduced activity. Acceptance networks activate. You discover that peace exists in present reality, not in changed circumstances. Solitude teaches that your worth isn't measured by external achievement. Social contexts constantly evaluate status and success, but alone. These measurements lose relevance. Your brain's reward systems recalibrate to intrinsic sources of value: growing, learning, experiencing beauty, being kind. Brain imaging shows shifted activation from external reward processing to internal satisfaction networks. You matter simply for existing, not for accomplishing. Being alone reveals that your breath connects you to all breathing things. The simple act of breathing, processed by your brainstem and noticed by awareness, links you to every organism respiring on Earth. In solitude, you can feel this connection. Your brain processes breath awareness as both personal and universal. Each breath participates in planetary gas exchange. You're breathing what forests exhaled, what oceans released. Solitude shows your brain that consciousness itself is miraculous. The meta-awareness that allows you to know you're aware becomes more apparent during solitary reflection. Your prefrontal cortex, observing your own consciousness, creates strange loops. Awareness, aware of itself. This capacity, unique to humans, reveals the extraordinary nature of ordinary experience. You're not just alive, you know you're alive. Your brain discovers during solitude that growth happens in quiet, like seeds germinating underground. Psychological development occurs beneath conscious awareness during rest. Neural consolidation, memory integration, identity formation, all proceed during solitary downtime. You're not wasting time being alone. You're becoming through processes social activity would interrupt. Solitude teaches that your story can change. The neural networks maintaining your self-narrative show plasticity during reflective alone time. Old stories about who you are become revisable. Limiting narratives lose their grip. Your brain can author new stories about your identity, capabilities, and future. This narrative flexibility, measurable through enhanced default mode network connectivity, creates freedom to become different. Being alone reveals that you're whole, not half seeking completion. Romantic culture suggests people are incomplete until partnered. But neuroscience shows complete neural integrity in solitary individuals. Your brain isn't missing pieces requiring another person. Relationships add richness, but aren't prerequisites for wholeness. Solitude helps your brain recognize its intrinsic completeness. Solitude shows your brain that you can trust yourself. The ventromedial prefrontal cortex processes self-trust through accumulated evidence of self-reliability. During alone time, you handle challenges without external rescue. You discover you're capable, resilient, sufficient. This builds neural foundations for self-trust that strengthen all future endeavors. Your brain learns through solitude that presence is enough. Social contexts reward doing, producing, entertaining, but alone. Your brain can experience being without doing. The simple fact of conscious existence becomes satisfying. This isn't passive. It's profound engagement with the miracle of experiencing. Brain regions processing reward shift from achievement to presence. Solitude reveals that death makes life precious. In quiet contemplation, your brain can process mortality without terror. Knowing life is finite makes each moment irreplaceable. The anterior cingulate and medial prefrontal cortex show patterns associated with meaning-making during mortality reflection. You discover that impermanence isn't curse. It's what makes existence matter. Being alone teaches that love includes yourself. Compassion networks in your brain, usually directed toward others, can activate for yourself during solitary kindness practices. Self-compassion isn't selfishness. It's extension of care to the one person always present in your life. Brain imaging shows self-compassion activates same regions as compassion for others. You deserve your own kindness. Solitude shows your brain that it's all temporary. Social connection, isolation, joy, sorrow. The posterior cingulate processes this impermanence. Understanding everything passes brings strange peace. You hold experiences lightly, knowing they'll change. This acceptance doesn't prevent caring. It enables deeper presence. since you're not clinging to moments you know will pass. Your brain discovers during deep solitude that separation might be illusion, the boundaries between self and world, self and others, consciousness and universe. All these distinctions, while practically useful, may not be ultimately true. Brain imaging during profound meditative states shows collapsed boundaries in neural self-representation. You glimpse possibility that consciousness is fundamentally unified, temporarily experiencing itself as separate. And finally, solitude reveals that you've always been both alone and connected, separate and united, individual and universal. Your brain holds both truths simultaneously. You're a distinct consciousness, experiencing unique life, and you're the universe experiencing itself through temporary human form. Solitude doesn't resolve this paradox, but helps you rest in it peacefully. Both truths coexist. You're exactly where you need to be. Here. Now. Aware. Breathing. Being. And so, our quiet journey through the science of being alone comes to a gentle close. We've traveled from the immediate neural changes when you first find yourself alone, to the deep recognition that solitude and connection both serve your becoming. We've discovered that being alone isn't what it seemed. Not isolation, but integration. Not loneliness, but meeting yourself completely. From your brain's first response to absence of others, to the profound realization that you're never truly separate from the universe experiencing itself. We've glimpsed how solitude is both shelter and teacher. Being alone reminds us that consciousness itself is the deepest company. Much of what matters most happens in silence. Neural integration, memory consolidation, identity formation, authentic self-discovery. Solitude reveals patience with yourself, resilience in your own presence, and the extraordinary gift of existing aware. Without regular time alone, you risk losing the thread of who you are beneath social roles. By pausing to be truly alone, you discover you're sufficient, whole, connected to everything, even in separation. In these final minutes, take the deepest breath you can, as deep as possible. Think about unity, how every moment of solitude and connection weaves into your life's fabric. You are not separate. You're a wave in the ocean of consciousness, temporarily distinct, but never truly apart. Every breath connects you to all breathing things. Every thought participates in the universe thinking itself. Let your entire being dissolve into the gentle awareness that holds all experience, not your personal awareness, but awareness itself, infinite and peaceful. Prepare for deep sleep. No boundaries left between you and rest. Only the vast presence that was there before you were born and will remain after you're gone. You rest in that eternity now. If this thoughtful exploration of solitude brought you peace or helped you feel less alone in your aloneness, a gentle like and subscribe helps other searching souls discover this quiet space. It might be exactly what another tired mind needs to finally accept themselves completely. One quiet tap, one peaceful night at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight, exploring the paradox of being both alone and connected, separate and unified. You can allow these thoughts to fade now, like morning mist dissolving into daylight, leaving only peaceful calm behind. Let your breathing deepen naturally. Let your body feel heavier, as if sinking into the earth that holds you always, held safely whether anyone's near or not. If sleep comes, let it carry you like a gentle current in a warm ocean, smoothly, inevitably, into a realm where loneliness and togetherness both dissolve into pure rest. If your eyes are still open, the next video is waiting, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, these questions about solitude will still be there. The universe will still be experiencing itself through countless forms. But tonight belongs to stillness, to the peaceful truth that you're exactly where you need to be. Rest well, gentle consciousness, and remember, you've never been alone. Awareness itself is the deepest company, and you are that awareness, temporarily forgetting itself to experience being you. Fall asleep to gentle facts, where science meets sleep. Dream deeper with bedtime science. Relax, listen, and drift into sleep. Good night.